So that being said, let's go ahead and kick it off. So quick note, some programming notes. Of course, everything is recorded. I see the recording button is on. So it is recording. You'll get a link to the recording after session. In terms of links to all the materials, there's not really any materials for today because we're just going to be using the app and using the plugins. But in terms of links to other important information like events and Discord and docs and all that, you'll get that in the email. If you do have a question at all, use the QA widget in Zoom. So everybody should see the QA widget should be on the bottom of your screen. If you don't see it, hit the more button and then the QA thing should pop up. Go ahead and just ask your questions there. There is no certification for attending the workshop. However, if you need like proof of attendance or something like that, you can respond to the email that we send with the recording and additional resources and let us know that you need some type of proof of attendance and we can do that for you. And so we'll start conceptually. I'll talk a little bit about plugins and all the various plugins that we have. And then we'll actually see some plugins in action. There won't be a ton of code unless, of course, we get to the point where we vibe code a plugin together. But, we'll uh, either way, we start conceptually. So if you're wondering if you're making a good use of your time by being here, you should ask yourself if you're in the right place. So I make the reasonable assumption that you already know 51 and you're looking to become a power user. And just based on the number of 51s I see in the chat, I think that's apt. If by any chance, if you're somebody here who's not familiar with 51 or maybe is brand new to 51, please do stay. You're welcome to stay. But you'll also benefit from attending one of our getting started workshops. And then, maybe spending a week or so hacking around 51. We'll drop a link to the getting started workshop in the chat here. Paula is riding shotgun with me, so Paula will be helping out with all those links. But yeah, if you're brand new 51, please do more than welcome to stay. And there'll be a link to the getting started workshop so you can attend. A couple of notes, just personal notes on my end. I feel like every time I do a workshop, like I'm sick. You know what I mean? Like I've got like some type of throat issue or cough issue, and that's I guess what happens when it's winter and you have kids that are in preschool and kindergarten, things like that. So I am a bit under the weather. I should also note that both my kids are actually home today. We have a nanny upstairs. My son has been stricken with something called the norovirus on top of his inflammatory bowel disease that he already has, ulcerative colitis. And there might be a possibility that they come downstairs for some emergency that they need me. And if that happens during this workshop, I need to tend to that. So appreciate you guys' flexibility for that. But I don't anticipate it happening. He seemed quite stable when I just checked on him a minute ago. That being said, if anything like that happens, please bear with me. So the agenda for today is we'll give an overview of plugins, talk about how to install them, give you just a high-level overview of, what the development of a plugin entails, just to kind of give you the structure of a plugin. Then we'll see this stuff in action in terms of like I'll show you how to use a plugin, and if time permits, maybe we'll develop a plugin together. And like I said, unscripted on the spot. I've planned to do this the last few times, but every time I've hosted this session this year, the last two times there's more 50s and 51s in the chat, so I never really got a chance to vibe code and build a plugin on the spot. But today, if we get to that point, we're gonna do that. And then I'll also talk about next steps. I'm Harpreet Sahota. I'm hacker in residence here at Voxel 51. And I've got education in math and statistics. I've worked as an actuary, biostatistician, as a data scientist. I've worked at several developer tooling startups, Deci AI, which was acquired by NVIDIA, Pachyderm, Comet, and a bunch of stuff on the side in terms of consulting. But I've been here at Voxel 51 for just a little over a year. Actually, my 1-year anniversary here was about 2 weeks ago. So who is Voxel 51? We're the lead maintainers of the open source library called 51. The whole point of this library is to make visual AI a reality, which means making good data a focus of your workflows. In terms of what a voxel is, it's the volumetric element of a pixel. So volumetric pixel is what voxel means. In terms of what 51 stands for, that's a good question. If people have any thoughts, go ahead and drop that into the chat here. I'm convinced that the founders had 50 bad ideas before the one good idea. Paula, not almost 1 year. It's been already 1 year. 1 year was about 2 weeks ago for me here at Box of 51. So what is a plugin? Let's start with that. Let's start with what a plugin is. So essentially a plugin is a software component that extends functionality of some existing software application without having to modify the core code of that library. So it allows you to not have to hack around with the core library itself, but then just add functionality that you create for your own workflows that are kind of based around that library. If you guys here are at all familiar with things like LangChain or Llama Index, these libraries have kind of a plugin ecosystem as well. Llama Index will have a Llama Hub. LangChain will have a LangChain community kind of installs. Same type of concept here with 51. And within the context of like open source libraries, like 51, plugins give you several key kind of advantages and they serve several purposes. At the core, they're just dynamic add-ons that extend the functionality of 51's capabilities, and they're building blocks essentially. You can snap them in when you need new features, remove them when you don't, and they're really just independent. So they're standalone modules that follow a particular implementation guideline. And we'll cover that a little bit. So you can install, update, and remove plugins really without touching 51's core code or disrupting your existing workflows. And the plugin architecture is really what makes 51 versatile. In fact, it makes 51 so versatile that the community members actually submit their own plugins. And we encourage that. We encourage the community to collaborate. You can create and share plugins that solve specific problems. And this actually makes 51 more powerful for the entire community. But plugins actually make it easier for you to do your work. So you can save time by turning complex or tedious tasks into essentially point and click operations or just one line, kind of function calls in the SDK. And this is nice because now you don't need to dig through old scripts. You can actually just dig through your data and focus on the data. So if you got like a lot of reusable things that you do across multiple data sets, well, you should probably make that into a plugin so that you can automate a lot of that. And if you think it's valuable enough or generalizable enough for the entire community, please contribute that to the community and share it with us in our Discord, and we'll get it added to our plugins page. But the point is, when you can better understand your data, you can understand your data, of course, but you can find data quality issues, train better models, and of course, better models mean more value. So by now, you probably want to see some examples of some plugins. So let's go ahead and show you some. One plugin is the utils plugin. And the utils plugin is a play on that. The utils plugin is a collection of dataset management operations that you can perform directly in the 51 app. So you can create, load, clone, and delete datasets. You could edit dataset metadata and properties. You can rename datasets, delete samples. You can compute metadata. You can generate thumbnails. You can, apply a saved view into your data set. You can execute arbitrary functions via the delegate operator. And they're quite powerful. Another plugin is the model evaluation plugin. So this is focused on model evaluation in 51. So it's a GUI wrapper around 51's evaluation methods, and it makes it easier to access model performance directly from the app without having to write any code. And this is useful when you want to quickly analyze how well your models are performing. So again, apologize for all the coughing, just my throat is kind of messed up. With this plugin, you can evaluate predictions for multiple tasks, classification, detection, segmentation, key point estimation, regression. You can evaluate your model performance and then get information and metrics about those evaluations. You can load those into the view. You can rename runs and rename those evaluation runs and delete evaluation runs as well, and kind of manage it all right there through the app. And we'll see this in action a little bit later. There's also the IO plugin, and this just focuses on importing and exporting within 51. So it's a GUI wrapper that allows you to handle common data input output tasks without writing any code. And this is useful for tasks like importing new data, merging data sets, or really kind of exporting annotated samples for visualization. So import samples from the media, from a glob pattern. You can import labels in the variety of supported common formats that we support. You can merge samples between data sets. You can merge labels between fields and just handle all that stuff right there in the app. So those of you that are familiar with the SDK, you've probably seen this done. In the SDK, it's just the GUI version of that. There's also the Zoo plugin. And again, this is just a wrapper around the Zoo functionality, and it makes it easy for you to access a lot of the pre-built data sets and models without having to write code. And this is useful for quick experimentation or when you want to try out different models on your data set. So you can download and load data sets directly from Dataset Zoo, configure the different splits and different kind of parameters that you might have. And you can do that with the dataset zoo operations, and with the model zoo operations, you could download and run models from the 51 model zoo, run different types of inference, such as generating predictions, computing embedding, computing patch embedding, so on and so forth. There's also the dashboard plugin. And the dashboard plugin allows you to create custom dashboards within 51, so you could visualize various statistics of your data set. So this is nice if you want to do some high-level exploratory data analysis about your data set. So you essentially access it by clicking the plus button next to the samples tab in the app, and then just, click on the dashboard, and then from there you can create customizable dashboards that allow you to do a wide variety of different types of plots as well. But beyond some of this high level kind of plugin workflows, we have plugins that do stuff that are a bit more kind of interesting, if you will. If you're working with, let's say, visual document recognition, you might be working with plugins, PDFs. Well, we have a plugin here that allow you to take a PDF and parse it into 51 format by converting those PDFs into images. Because if you have experience with 51, you know that 51 needs to be tied to some media type. Typically, that media type is a visual element. So this plugin will take your PDFs, convert them into images, load them into 51 format, and then you're able to load the PDF pages as samples in the 51 data set. And this can be integrated with actually other plugins that we have for more advanced kind of document processing. We have a plugin for PyTesseract. We have a plugin for semantic document search. And then also we can use this in a sense for visual document retrieval. So kind of building on that last plugin that we just showed, once you have your PDFs loaded, you can actually use the OCR. Apologize. The OCR and semantic document search plugins. And this is useful if you want to search through the raw text in the actual PDF itself, but you can compute embeddings on different sections of text and then visualize them in the embeddings panel. And an example of this drop a link here to a Google Colab. Example of this is what I did last year for CVPR. And I dropped a link here in Google Colab. Let's see if I can pull it up real quick. And in this example here, I took a bunch of different accepted papers from CVPR, create a data set with them, and then use the different plugins that we have to help you uncover research topics that are interesting to you. So you might want to check that out. Another interesting use case is creating an AI art gallery, for example. So we have plugins that allow you to create data set with synthetic images. In this case, it's the AI art gallery plugin. And so the way it works is you can select from a variety of different diffusion models, pass in a prompt, and then iteratively kind of create a data set of synthetic images. You can build a reverse image search plugin as well. Of course, these plugins that we've shared, these are already built out, but these are just examples of types of plugins you can build. This particular plugin is a reverse image search plugin. So let's say you have a large corpus of images. You've got some new image coming in, and you want to find images that are similar to that new image. Well, you can do this type of reverse image search. And this will help you find, let's just say, for example, like in production, you've got some data that comes that's a bit weird, that's a bit wonky, and you're curious if your actual data set has anything similar to that, like the one that you trained on. You can then do this type of reverse image search with this weird wonky image to kind of see if this type of stuff has shown up in your training data. And of course, in certain use cases, this can help you understand how you need to enrich your training data or where you might need additional coverage. This example here is actually an example for cross-modal retrieval. So this is a plugin that was built based on image bind. And I'm going to try to share here with audio because it's a lot more powerful. So how do I do this? Let me share in a different way. Share a screen and share sound. And we'll hit play here. And so what we're going to do here is we've got a data set here, in this case, Coco, uploading an image, sound of a train. And we're going to search based on that sound. So we hit search and it pops up with all the images that make that sound. So this is a cross-modal retrieval type of plugin that's based on the image bind model. All right, let me just see. There's a question coming in here in Q&A. Now, reverse image search, are you using classification for the plugin? No, in this case, it's embedding-based search. Of course, everything is open source, so you can always look into the source code of that plugin and see how it is that plugin was built. But in that case, it's based on embeddings. So the list goes on. There's so many different types of plugins that you can build. There's built-in plugins that we have internally that are official Voxel 51 plugins. But there are plugins here that that allow you that the community members have built that allow you to do some really interesting stuff. So definitely worth checking out our repo for plugins and kind of finding one that might work for your workflow. I recently wrote a blog that made use of the audio loader plugin. Paula, maybe if you can look that up from the Voxel 51 blogs page. And I use the audio loader plugin to load in audio as MEL spectrograms and try to see if VLMs can classify uh, audio based on the MEL spectrogram. And that was mostly just for my own understanding of what a VLM could do. The results were, well, the results were what they were, not that exciting. But it was a fun plugin. Sorry, it was a fun project that made use of several interesting plugins that we've created. And it was well worth the time spent. I really enjoyed writing that blog. We'll get a link to that pretty soon. But plugins, the list keeps growing and growing. Whatever the use case or workflow may be, if you can code it up, you can turn it into a plugin. So how do you use these plugins? Well, step one, browse through some of the plugins in our plugin repo. And here's a link to the plugin repo. So be sure to start the repo and watch it because it's being constantly updated. Step two, visit the repo for the plugin of interest. Take a look at the README. It'll usually have the instructions for everything that you need to do. And then once you're ready, you download and install the plugin. And there's a couple of ways to do this. One, you can download right from the terminal. Another way you can do this is download via Python. Once you've got that done, once you've downloaded the plugins, you can load your favorite data set. For example, the quick start, and then launch the app. What you want to do is then look for this icon, this kind of hamburger menu icon. In this case, it's the browse operations icon. And this will open up the operations panel, which will look something like this. And then from here, you can search through all of your installed plugins that you might have. You can then click on the plugin of interest and fill out the form. Alternatively, you can actually run the plugin programmatically in the SDK. And so this is the pattern for doing that. And after that, you just kind of sit back and relax and let this kind of run and let the plugin do its thing. And then you'll have results. But how does this all work in the back? Operators. Operators are all you need. So they execute as, you can execute an operator as a delegator, use it with orchestrators. And essentially, this has all the I/O, the execution, placement, configuration, delegation, all done within this kind of operator. So the operator interface looks something like this.
It's 11:30.
The operator will have some type of configuration. That operator is operating on some context. That context can be your data set. It could be a view. There's placement of information via the UI. The operators will have some type of input. They'll give you some type of output. And everything is done in the back through the execution of the operator. And of course, you can also delegate an execution. And delegation is essentially, if you have like a compute node, you can delegate it to that compute node. If you're working locally, that compute node is just your one local computer. But the kind of anatomy of a plugin looks something like this. There's two main elements. There's the Python operators. And the Python operators handle and run the ML computations, and there's JavaScript for custom UIs. But the distinction isn't really cut and dry. There's a ton of interactivity in Python. Oh my God, I'm so sorry, guys. Rough. So there's interactive activity in Python with the logical components in JavaScript. You don't really need to know any JavaScript to create a plugin. If you are a JavaScript developer, you can write JavaScript, based plugins, but to need, but you can write entirely in Python, entirely in JS, or some combination of the two. There's communication between uh, Python and JavaScript. Of course, we're going to focus on Python plugins, but that's the main thing we'll be working with. I do want to call out that there is a newer kind of functionality called Python panels, but we won't be talking about Python panels today, strictly on plugins. So starting with the directory structure of a plugin, we have the 51 YAML that kind of declares a plugin and information about it. We'll see what that looks like in a second. And the init.py, this is like the the most kind of important piece of the plugin. It defines and registers the operators. If you want, optionally, you can have a requirements.txt and then a README for just information on how to use the plugin. You can choose to write everything in the init file, or you can have some helper files, optional helper files, and then just import everything into init. But init is like the necessary component. I choose to kind of build stuff out in a more modular way. I'm so sorry, guys. I thought I'd be able to make it through without coughing too much. The 51 YAML file, this just has a bunch of information about the plugin. We've got the name of the plugin, author, all that stuff. And the most important part is, of course, like the listing out what operators we have, because then they'll be registered. Here's an example of what an operator looks like. So the operator is essentially the user-facing kind of operation that allows you to interact with the data in the data set. So the operator has a configuration file, or rather just a configuration method that we have discussed already, ways to handle the input, ways to handle the output, and then the actual execution that happens. So we can accept parameters via the user import forms or properties, or we can execute actions based on those inputs. And then we can optionally return outputs if we need to. But these operators can range from really simple actions like checking a checkbox to something more complex, like maybe requesting annotations from a configuration backend. These can be written in either Python or JavaScript. They can be executed directly in the app. They can be triggered by other operators, or they be used as building blocks to create more complex workflows. And this is really powerful because we're defining operator input and output without really needing to build a custom user interface from scratch. Everything is done right here in Python, and it'll populate and create the form, so you don't have to worry about creating the UI form. This simple example is just taking text from a user and displaying that text back to the operator's output modal. There could be more complex examples they can build on this. For example, model inference, data transformations, or integration with some other kind of external service. Here is kind of the operator config's anatomy, if you will. As I mentioned, the config is responsible for defining the kind of core metadata and kind of behavior settings of an operator. And it has some key components. One is that we need to have a name and a label. So the name is the URI that's formatted as like kind of plugin name / name. Just move this to the end and then hit pause here. And then there's a bunch of optional settings that you can have. For example, basic metadata, such as the description, whether it's going to be dynamic. By dynamic, I mean whether we re-execute resolve input after each input from the user, whether we want to execute this as a generator, whether we want to have this run on startup. So whenever we start a new app session, do we want this plugin to run? Or whether we want it to open on a particular data set. So when a new data set opens, do we want the plugin to run? There's also information that we can pass in terms of visibility. So we can hide the app's operator browser if we want to. We can also handle some execution modes. Yeah, hot tea and honey. I definitely need some hot tea and honey for sure. I'll be getting some after this. I know I talked about doing vibe coding of a plugin. I don't think I'll be able to talk that much after this. But perhaps we should set up some type of session during like a, I don't know, if there's interest in it, drop this in the chat, right? We do a weekly developer hour every Tuesday. And that weekly developer hour is just like general questions that you have related to 51. But if there's interest for like a plugins hour where you want to come in and ask questions about plugins and get help building a plugin, if there's enough interest, we can do that. Or hopefully by the next time I run this workshop, I'll be better, and we can vibe code a plugin together. But you can build and ship your first plugin this afternoon today if you wanted to. How can you do that? That's a good question. So here's how you would do this. I would say find a model on Hugging Face. Initially start to hack around with the model, right? Just see if you can, get that model to run and iterate across your 51 data set. Then what you want to do is make that code more modular. And you can follow a format that's kind of similar to this, for example. So just opening up my GitHub here. Let's just look at this plugin for Moondream 2 that I recently have made. By the way, Moondream 2 is such an awesome model. I'm a big fan of it. But here, for example, right, what I've done is I've made this modular in the sense that Moondream does a few different types of operations. We can caption. That caption can be short or normal length. We can do VQA. We can do detection, and we can do key point. And so what I'm doing here is first I'm going to make this module modular by subclassing from 51's model type, which you can see here. Define an init, and this init is just going to download the model and take care of some stuff, such as setting device and just initialize the model. The 51 model type needs to be defined by a media type. So in this case, we're going to be working on images. And then I'm creating a bunch of little internal methods to parse the output of Moondream into 51 format. So in here, I'm getting all the detections from Moondream, and I'm going to parse those into 51 format. So 51 format for detections has a particular kind of format that it requires. And I'm converting that into the required format. And then for each image in the data set, create a list of detection objects. If I'm working with key points, then of course I can, write a helper function here that takes Moondream's key points and outputs it into 51 format. Same thing for caption and query. And then I have other helper functions that, based on what it is that the user wants to do, how do I want the plugin to behave? So in this case, if I'm doing detection, well, then I need to set the model to detection mode, which I could do here. And then once I have all those detections from Moondream, I need to get them into 51 format. So I send it back up to that function that we just, internal method that we just looked at. Same thing with point, same thing with the queries as well, the query and the captions. And then finally, I can run this on my entire data set. So here is how to predict on a single image, right? So just write a method to predict on a single image based on the prediction method that we've chosen. And I can now apply this to the entire data set. So this method will access the media type. With that media type accessed and converted into this format, then we go into this predict method. And because I wrapped everything in the 51 model, I can use the 51 apply model method of the dataset object and run all of that on my 51 dataset. So in a sense, fairly straightforward, just to modularize everything. And all these helper files are, everything we just said right there was in the helper file, but then I import all of this into init. And this is where we handle everything in terms of 51 operator. So all this stuff here will help me kind of populate the different types of versions that are available for Moondream. And then I define the operator here. So I've got a configuration, just specifying the name, label, description of this operator. How do I want to handle the inputs? So when this operator is executed, when I'm using this operator in the app, what do I want to have populated on that UI? So in this case, it's a model dropdown. It's the revision dropdown. So the user's going to be able to select the model, select the revision of the model. They'll be able to choose a operation type. And so the operation type is, caption, detect, key point, query, right? And, if they choose caption, do they want to get a short caption or a normal length caption? If they choose query, then do they want to, they need to provide some type of text for the query. They choose detect, and what is it that they want to detect, right? So this is how the user is going to operate on that plugin or interact with that plugin. So just kind of pulling it up here. I'll pull it up to make it more concrete when I launch the app a little bit later. I thought I had a GIF here showing you how to do it. But all of this here is how we go from what's in the input, what's in the UI, and how we parse this in from the user. And then from here, right, once we have all that context that we've saturated from the user, how do I execute this? So I get all the information that I've taken from the user, all that context that I've saturated. And then from there, I run the model on that data set. If I want to run this via the SDK, I've implemented the call method here that allows you to run it via the SDK. And of course, I need to register the operator as well. So high level, how that's done. Question here. Do we support using inference, using multiple GPUs in parallel? Yeah, you can, on the enterprise product, 51 Teams, when you delegate an execution to a cluster, it will handle that for you. The open source version, we just treat your local machine as one cluster. So if you have multiple GPUs in your local machine, then yeah, I guess technically you could run multiple GPUs in parallel, but you would need to handle that in code yourself, right? Like we can't automatically, kind of infer that parallelization for you. You'd still have to define that, how that's being parallelized in code. And you could do it right here. Sorry, in this file. So yeah, you'd have to handle all that logic yourself, but yeah, you could definitely do that. So once you've created a plugin, well, the next step is publishing it. So you could submit a PR to the 51's plugin repo. And, add it to here, and it'll be readily searchable and available to the community. So now let's go ahead and just kind of see all this in action. So let's start, let's just work with the plugin here. All right, so here's what we're going to do. We're going to use the IO plugin to load data from disk. Sorry, I'm probably not showing the right screen, am I? Do you guys see my code? Just Paul, can you confirm that you see? Okay, yeah, you guys can. All right. Wait, maybe you can't. Hold on. Okay, so all right, so just kind of walking through the game plan for today. We're going to use the IO plugin to load our data from disk. And then from there, what we're going to do is make use of the utils plugin, handle some basic stuff, do some image quality metrics, create a dashboard, analyze those metrics, compute some embeddings, and then use zero shot prediction to make some predictions and then assess those results using the evaluation plugin. And then finally, we'll push this to the Hugging Face Hub. I'm going to be using the 51 app in the browser. You could, of course, use it right here in the notebook, but it's a bit clunky using it in the notebook. If you're using it in the notebook, you'll have to set your environment variable like this. If you're using it via the terminal in the app, I'll show you. You just set the same environment variable as well. We'll do that in a second. And then we can start by downloading some plugins. So downloading plugins is quite straightforward. You can use either pattern that I showed you, strictly using Python or using the command line. Here I'm just using everything via the command line. So I'm downloading a few plugins, the IO plugin, the dashboard plugin, utils, and evaluation plugin. So a few plugins that we're going to be making use of. And then I'm going to download this Hugging Face plugins that allow us to push the hub straight from the app. And then some community contributor plugins. So in this case, there's a image quality issues plugin that we'll make use of. Zero shot prediction, doing embeddings with the AIM2 model. And when it comes to installing plugins, there's a couple of ways you could do it. You can say 51 plugins, and then like 51 plugins requirements download, or you can more explicitly just install the requirements like so. So you can see here 51 plugins requirements, right? That's one way to download with the requirements. The other pattern is to download the plugin and then install the requirements. So a couple ways. We'll drop links to the docs for using plugins, so you can check that out. We'll look at the Moondream plugin as well. This is a, what I just showed you kind of that we built out, how I built that out. And we'll kind of just see it in action with the operator as well. And what we're going to do, we'll create an empty data set, and then we're going to load a sample set data set. So as mentioned, since I'm going to be working strictly from the terminal, I need to make sure that I've got my environment variable set. I think I've done this already previously, but let's see if I have it set. All right, so I've already set it. If you hadn't set it in your terminal, it'd just be export and then true like that. This is just something we need to do to make delegators work with open source. All right. And now what I'm going to do is I'm going to go ahead and instantiate an empty data set here, call it wonders. And I'm going to launch the app. So I'll go to the terminal. Say FiftyOne App launch. The browser, here. And now what I'm going to do is scroll down here to wonders. No samples yet, which is fine because I haven't added samples. I'm going to hit the backtick button. Backtick button will open up this operators panel. Sorry, the operators browser. I'll say import samples. I want to import media and labels. The type of structure I have is going to be an image classification directory tree. I'll call the label ground truth. I'll specify where it is that these images live. Right. So you can see here, this is image classification directory tree format, right? So I go to the top level where those images live. So you'll see there's like a little bit of nesting. So I click on this and then I click on this, right? So what I want to really import from is here because this is in this top level directory is where that structure inside of there is where that structure is. So I'll hit choose and then I'll hit schedule. And then I'm going to backtick again and say reload the data set. Hit reload the data set, or rather just control R. All right. This is funny because I was just working on this and verifying that everything I wanted to do was actually going to work. All right. What was it? Plugins workshop. Hit execute and execute. There we go. The reason I didn't have a delegated service running at that point, so this is why that didn't work. All right, so going back to this here, right? So what I'm going to do is just in the code, I'll hit data set reload, right? And we can see programmatically, I could verify that I've got my data set here, right? So I can now interact with it programmatically if I want. So what I'm going to do now is I'm going to open up another terminal session. Make sure I got the right environment running. I'm going to kick off a delegated service because we want to make use of this. So I'll say 51 delegated launch, right? So now I've got a delegated service running. Yeah, and so it's redoing that service that I scheduled, which is fine. So hit run here. I've got everything that I need. And now there's a couple of things that we could do. First, I want to do is I'll open up the operator panel again. And let's look at the image quality metrics library. Sorry, plugin. I guess something we could do real quick is maybe, well, first let me just see something. Do I have any metadata? Okay, I don't have metadata here. So I might want to get my height and width of my images. So let me just compute metadata real quick. So compute metadata. Um, and let's just hit that. And when we go back to here, we can see, all that information. So my data set size doubled because, well, I added samples to there twice, which is fine. Um, all right, so we now have metadata. Right, so that's good. Um, and now actually what I want, you know what? I don't like the fact that I've got double I've got duplicate images. I don't like that, right? That really is frustrating. So let me just delete this data set. So I'll delete the data set right there from the app. Yes, let's just go ahead and delete this, right? You can see here now it's no longer here. We'll just create a data set again. We'll just call it wonders. Um, we don't need to make it persistent. We'll execute, right? So it's empty-ish. Right, it's empty. I'll go ahead and import my samples again. Yeah, it was a bit frustrating having everything duplicated, especially because I want to run some stuff. So ground truth, directory. Of course, we've seen how to do this already. So let's go back up here to workspace, plugins workshop, choose this. Um, we've got a delegated service running already here, right? So I'll just hit schedule and you can see it's status bar running. I'll hit R to refresh. All right, cool. So this is good. Um, of course, no metadata again. So let's just do that again. Let's, compute the metadata. We'll schedule that since we have a delegated service running. Reload the data set. Might need to do a hard refresh of the app. All right, cool. So we got metadata here. That's great. So I can, of course, filter based on like super high resolution images if I wanted to. Right, so I got some fairly large images there. Great. Now, as I promised, that's carrying on here. Let's go ahead and just compute some. Let's compute some. How about uh, mm, how about brightness? Do you guys want to compute brightness? Yeah, let's compute brightness. Why not? So this might take a few minutes to run, but I'll click delegate execution, hit schedule, go back here, look at my terminal. We could see that it's running through all these samples in the data set. So it'll take a few seconds to complete. And what we're going to do is then kind of use the dashboard to explore this a little bit more.
It's 12 o'clock.
While this is running, right, there's still about a few seconds left. So I'll just go ahead and hit the plus button here, open up the dashboard, open it side by side alongside the sample viewer, hide this thing out of the way. Let's add a plot. Let's do a categorical histogram, and let's just call this frequency, and maybe class frequency. Let's do ground truth labels. Let's order it based on frequency. Let's create the plot. All right, so now I can kind of see the distribution of class labels here. I can create another plot. So we'll add an item here. Let's do a scatter plot actually. Let's do a scatter plot, and we'll make this we'll call it image resolution. Okay. On the Y, we'll do the height. We'll call this height, of course. On the X, we'll do width. Right? And then we can create the plot. And now we can kind of interact with this. So I'll use the lasso select, and then I can just highlight all of these, which are, fairly high resolution. And everything kind of filters down right here. I can get an understanding of, okay, what are the most high resolution images in terms of like the place and what do those images look like, right? And so that's pretty useful, I would say. So go ahead and let's go ahead and clear this out. Oh, I should have saved those plots. That's what I really meant to do. That's fine. We can see here that the image, quality metric stuff has done computing. So I'll just go ahead and let's just do a maybe a numerical histogram. Of course, like I accidentally closed out those graphs. You can have like a dashboard how you want it and then save all those as well. Just following the exact same steps that I just did. So look at brightness. And maybe we want to do maybe like 30 bins or something. Maybe we could change the number of bins. And then once that's done binning, we can hit, create the plot, and that'll be added to the plot. And then we can build dashboards and kind of, just like I was showing you before, interactively click around and kind of see what those samples are that are, meeting those, that are in those plots, right? So that's a few things we could do for some initial kind of exploration of the data set. So that's quite nice. Another thing we could do is actually what I'm going to do is I'm going to open up the operator panel again. And there's a plugin that I built for this really cool model. If we go back to my GitHub, go to repositories, and I want to look for AIM. So AIM embeddings is the AIM model was put out by Apple late last year. Really good model. And I don't think it really gets the recognition that it deserves. Like, such a good model. And what I'm going to do is I'm going to compute embeddings. So yeah, going back to my app here, and I'll just type in AIM, compute embeddings with AIM. Which model? Let's see, let's just use a small model. Let's just stick with this one. That's good enough for me. So you can see here, if I go back to the AIM embeddings code, if I can open it side by side alongside with this. If we go to the AIM embeddings code and I look at the init.py, we can see where I've created that operator, right? You can see here all the stuff that pops up. So when I hit the backtick, compute embeddings with AIM v2 model, right? That's the label, the name of the operator, compute AIM embedding. So I defined all that stuff here. When I click on this, I get the description, right? Compute embeddings using AIM v2 model, right? And I'm resolving the input now. So the model dropdown, I'm defining it right here in Python. I've created a dropdown up here, and I'm importing it from my helper file. But I'm now resolving the inputs. So here's the model I want to use. Evaluating that here. So embeddings type. So you can see I've defined it as a radio group. There's two choices, class or mean. And you can see the labels correspond with it. The descriptions correspond with it as well. I'll just do mean pooling, right? And here, embedding field, the name of the fields you want to store the embeddings in. So you can see it corresponds right there. And I'll just say AIM embeddings. And then right here, handle delegation, right? And you can see everything that I've defined here pops up on this UI. So I haven't really written anything beyond just a little bit of Python code. And it is populating and saturating this UI. So quite nice and straightforward to do. Right. And then when I hit execute here, I've delegated the execution. When I hit execute here, what's going to happen is I've saturated all this context, right? So the view in this case is just the data set that I'm working with. The model name, right? I've got that already. The embeddings field, I've put that here. The embeddings type, I've put that here. And then I'm taking all of this information and I'm going to the run embeddings model, right? And so this run embeddings model, if I can just open up here and show you, I've defined it in a separate file, right? The run embeddings model is coming from here, scroll all the way down to the bottom, and I'm taking all of the stuff that I've put into my UI and I've put it right here, and I'm passing it as arguments to run embeddings model, which is just doing everything that I define up here, right? So that's really nothing more to it, right? This right here, this call, this just makes it possible for me to run everything via the SDK. So if I wanted to do everything via the SDK, I could. And the way I would do that is I would first instantiate the operator, as you see here. And then I would, with that instantiator operator, I'd pass in the arguments. So in this case, the data set, the view, right? Like in the app, I don't need to define the view because I'm in that view, passing the model name, the embedding type, and the embedding field, right? So you could see that correspondence from what's in the app to what's I pass into the SDK and how the plugin works behind the scenes. So hopefully that kind of makes stuff clear for you. And now I just hit execute. And this, I'm just going to exit. I'm not going to exit that. I'll just move it here, move this guy here. And the AIM model is relatively quick. I mean, a minute for 3,000 samples. You can't hear it, but my GPU is chirping right now. Can I explain embedding type? Yeah, I mean, this is just specific to this particular model. So here, rather than talking, because it's going to distract us from what we're talking about, but I define it here, and kind of tell you what that means. So, so I'll drop the link here. You can read it on the README. It's just, do I take the last layer and that vector, or do I average over the entire feature map? And this is essentially what I'm doing. So that's what that means. It just gives me a different representation, essentially. So this is running in the background. If there's any questions in the meantime, keep it coming. And I'm surprised I just haven't been coughing over the last like 10 minutes. I'm honestly very surprised. All right, so we run that operation. So just we can call the data set again, right? And you can see I've called the data set again in the notebook session, but nothing is there. So I need to reload it. Then when I reload it, I see that I have all those fields that I just added, right? So now, in order for me to visualize the embeddings, so if I go here, right, and I hit embeddings, this one-click embeddings in the app, this is actually, an enterprise feature. Of course, we can't make everything easy for open source. I guess we got to make money somehow, right? So our enterprise feature makes it really quick to do one-click embeddings. Paula can link to that if you're interested. But open source is really not that hard. You just need to run this line of code. So I'll run this line of code. What was my embeddings field called again? AIM embeddings. Great. So I'll run this. This is running UMAP for the embeddings and just projecting it down to 2 dimensions. So I'll hit that. It takes just a few seconds for it to run. So it'll run, it'll do its thing. All right, so that's done. So now I can click here and click on embeddings. Well, maybe I should hit reload. Click on embeddings, and now I can say embeddings, AIM v2 embeddings, and I can color now by label. And you can see like this model picks up some really interesting representations, right? Like it clusters everything so nicely. So I can click around here and see, oh, okay, like actually everything's Statue of Liberty. Click around here. Okay, actually everything is Angel Falls, so on and so forth. Another thing we could do, we can apply a zoo model. We could do a built-in model here. Let's look for an embeddings model. What model do I want to use for embeddings? How about we just use clip? And let's just call this clip embeddings. Batch size. Let's just do batch size 128. I didn't support batching with my plugin, but you can always fork it and support batching if you want. So click schedule, go here. We can see that this is running clip, nice and fast. Now, of course, if we go back to the app here and I call my data set, my clip embeddings aren't there yet. So I need to reload. And you can see now that I've got my clip embeddings. And so now I could just, again, run the same thing, passing clip embeddings instead. And of course, this will take a few seconds to run. It runs. Control R, open up the embeddings panel, right? And where is the, oh, that was stupid of me. I kept the name as aim viz. Okay, I should have called it clip viz. This says aim viz, but it is in fact clip embeddings. Okay. Hold on. Wait, let me fix this. Let me fix this. All right, we'll call this clip viz. This is why working with notebooks sucks, right? Or why it's not recommended. But we're trying to teach here. So we'll do this again. And this will take some time to, there you go. Close this out. Reload the data set. Control R. Open up the embeddings panel here. All right, now we got them both. So you can see clip embeddings, compared it to the AIM representation, right? So we could see both models do a decent job of finding separation. Up here with clip, this is all the Taj Mahals. Up here with AIM, all the Chichen Itzas. So, different models, different representations. So yeah, there's that. So high level exploratory data analysis. Of course, you could do a lot more. I don't want to get lost looking at embeddings right now. What do I want to do next? Yes, zero shot classification. So let's go ahead and do some zero shot classification. So open up the operator panel again. I'm going to type into here zero shot classification. AIM v2 actually has a classification model. There's like multiple checkpoints on AIM v2 on Hugging Face, but they only released one that you can do for zero shot classification. I have all my labels here, so I don't want to type them all out. So I got all my labels here. We'll say AIM v2 predictions, delegate that execution, hit schedule. We can see here that that's running. In the meantime, since that's delegated, I'll open this up again, and then I'll say zoo. I'll apply a zoo model. If we wanted to apply a zoo model, we could do a zero-shot classification. I go here, clip. We'll do we could do either embeddings or predictions. Label field, we could do clip label field. But you see, kind of a bug, and maybe something I'm going to raise internally, is that this plugin actually doesn't support us specifying which labels that we want to choose, right? So that's kind of frustrating. So that's not quite nice. But what we'll do is we'll just go ahead and go back to the zero-shot classification. We see we got clip. We got a number of different models that we can use. Maybe we want to use, let's just use MetaClip. Why not? And there's a few different architectures we can change from. We'll just use the small one and put the labels from file. Haven't input from file. I'll call it MetaClip predictions. We'll delegate. I'll hit schedule. You'll see that this one is still running, right? The first one is still running, the clip one. After that one's done running, I've scheduled that operation to run next, so that'll run next. And while that's running, just kind of taking you through another tour of the operators panel. And just how about just making it clear again. So actually, before I do that, like when you open the operators panel, you can just type in plugins, right? If you're not sure what plugin you want to use, you can do install plugins. You can install plugins strictly straight from the GitHub rather, or you can go to Voxel 51 and take a look at some of the official Voxel 51 supported plugins. You see there's a number of them. Or you can look at the community contributed plugins. I need to do that today. I need to push my plugins to this. But you can look through here and you can like search plugins that you want to download as well. So for example, you could do an image captioning plugin if you'd like. Mine is not yet on here. I've got like 12 plugins I built this year or something like that, like something crazy. I need to add them all to here. But just pull something up. Remember, we're walking through the Moondream plugin. So I just want to show you kind of the relationship between the Moondream plugin. Let's do this again. This is not working. Okay, cool. So again, the Moondream plugin, looking at the init.py, right? Defining the operator, we have the config, right? And we open this up, we type Moondream. What's the label? Run Moondream 2. What's the name? Moondream, right? Everything that we populate here from the input, right? Inputs, enumerating a list of inputs with which revision do I want? I select from the available revisions. What do I want to use it for? Right, so the operation. Select one of the supported tasks, right? What do you want to use Moondream for? And in this case, I could do something like caption image. If I caption an image, right? If I'm captioning an image, then what length do I want? I should pop up the radio for length and then give me the options. Short caption. Output field, right? Capturing that right here from the user. And it turns out output field. Likewise, if my chosen task is visual question answering, it dynamically changes, right? If task equals query, then this thing should show up. If task is object detection, then this thing should show up. If it's point, then this shows up, right? And I'm saturating all the context behind the scene. And as we saw before, this will all get piped into the execution down here. grab all that stuff from the saturated context, and then pass it to the uh, actual function that will run inference on the data set. So that's what that does. Um, so real quick, we'll just do captions, a short caption. We'll call it Moon Dream. Call it Moon Dream caption. I'll click delegate execution. I'll schedule it. This will take a few minutes to run, but in the meantime, let's do some other stuff, right? So this is running, but it's not going to prevent us from doing our 29 minutes. I don't got 29 minutes. All right. That's running in the background, whatever it's doing its thing. In the meantime, we can carry on with our life. So I'll open this up now, and what I want to do is type in model evaluation. So I'm going to evaluate my model. I want to evaluate my AIM v2 predictions against the ground truth, and then we'll call this AIM v2. We'll do simple classification. You could choose between these. We'll just make it simple. Classes, we'll just see the default classes on the data set. Instead of schedule, I'm just going to go ahead and just execute right now because I don't want to queue it up, right? Because you can see here I've got this thing running. I don't want that. Why do I keep losing stuff? There we go. I'll just execute right away, right? And we can see it pops up right here. Evaluation key. Let's do it again real quick before I open up the evaluation panel. Predictions. Let's just call it meta clip. Against ground truth. Meta clip. Meta clip eval. Go ahead and execute this straight away. All right, we'll reload the app. Right, we see that that's here. Hit plus, I'll hit model evaluation. We can see the model evaluation pop up. So I can click on the AIM v2 model evaluation. I can see kind of the performance of the model, right? I can look at class-wise performance. I can actually open up a confusion matrix and kind of see the model performance. I could also individually look at the meta clip performance. That is unexpected. You know, one of my kids, their favorite thing to say nowadays, and it's going to be quite fitting right now, is womp 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 womp. Yeah, I'm not sure what happened there. Um, yeah, that's I wonder if it's just in. Yeah, I don't know what the issue is. My apologies. Um, it worked earlier today. I think maybe having the Moon Dream running in the background is causing me an issue, but that's fine. But what you could do is do this and then compare it against this, and it would typically work. But of course, you know, I wasn't going to get away that quickly with a smooth demo today, was I? Right? I thought everything was going my way. Um, I'm going to go ahead and just cancel this because I'm not going to make you sit around half an hour to see captions. Um, right. And let me just restart the delegated service here. Just for my own. Uh, let's just try to make it work. Schedule there. It's completed. Hit Control R. Model evaluation. This compared against this. There we go. Up, I don't. Yeah, I'm not sure what happened. Um, I can promise you, in my dry run earlier today, it worked just fine. But there you have it. We've did a lot of stuff just programmatic, not programmatically, but without writing any code, and right there in the app. So just strictly using nothing but plugins. We've explored our data set, computed image quality metrics, ran models against the data set, did an evaluation of the model, and then we're able to, uh, you know, do model evaluation in the panel. So look at a model evaluation panel. Yeah, so that's it from me, and that's it with the plugin workshop. So if you're wondering what the next steps are after this, well, go ahead and give a star on GitHub, follow us on LinkedIn, give us a try, uh, and feel free to join our Discord community. And with that, hour and a half is up, uh, and we're calling it a day. Thank you, everybody.